Hello all and welcome back. So now let's find the time complexity of a problem which we have solved before, finding the largest element in an array. So the approach which we actually followed in finding the largest element was something like this. We were given an array or a list, right? And in that array or a list, we have to traverse the full list and finally tell which is the maximum array, maximum element, right? Now we used to assume the first one as the maximum and then go to each and every of my element, right? At each point, and again always remember that you have to assume the worst case possible. So this will be a fully sorted array in increasing order where the last element will be the largest. At each and every point we will be doing some operations. Those operations will be something like this. So if a of I, it should be greater than, let's say, my current max, right? Then we used to change the current max to a of I. This was something of a code we wrote. Now doing these things, I am saying that this is some k operations, right? So I'm just taking a constant k. These are some k operations. Now, because we are assuming that max will be at end, at each and every step, I will be, so at step first I will be doing k operations, at step second I will be doing k operations, at step 3 again k operations, and all the way till n I will be doing k operations. Now if I add all of these k operations which I have done, it's actually the summation is going to be n into k, right? So I will again repeat the whole process because it's going to be a lot helpful. We have already established many things through our earlier videos. Highly recommend to see them if you have skipped them in any chance you have not seen them. That we are actually worried about the number of operations, right? We have seen that we don't care about the time, we have to see the number of operations. Then via the asymptotic analysis, we also understood that how we are interested in finding the order of on which the time will depend and not the exact time, right? Now what I'm saying is that in the problem of finding the maximum, first and foremost thing is that we are actually finding the big O complexity, which is the worst case complexity. And in my worst case, this array will be sorted like this. So the maximum element is going to be in the end, right? As it is in the end, at each and every step, I will be doing some key operations. I will be, of course, first comparing my current element and the current max. Then I will be updating that, right? So some work my particular CPU or my overall algorithm have to do. Now this k operation I will be repeating. This k operations a lot of times, as we can see. So at first I'm going to do some k operations, then at second I'm going to do some k operations. This is basically the each and every iteration, right? At third iteration I'm going to do some k operations. When in the end I will reach to the nth iteration, the last element, I will be again doing some k operations, right? If I submit all this k operations, then this is k plus k plus k n times, thus nk operations total, right? Now if this is where my time complexity depends, this is actually the order of which it depends, then of course to find the big O complexity, what I can say, it should be less than some c into g of n. I can take my g of n as n here and c as, let's say, k plus 1 here. Now this is upper bounded. That's what our big O complexity used to say. Big O notation basically. We have seen the graph as well. And based on this, now I can say that my complexity is going to be O of g of n, which is O of n. And this actually is linear time complexity. Right? Great. So there can be few more operations if you are thinking that while I was taking this max and let's say if I am returning in the end, then yes, these operations will be just an addition. Let's say you are doing some 2 or 5 operations, but we have already seen how we are always focused on the highest order term. So when the input size will be a lot large, say I'm talking in terms of billions, right? Then your small constant operations will not matter. This is something also which we understood visually via graph. I made sure that I'm explaining that properly, so that you always remember this thing and even able to explain it to anyone further, right? So this is the reason we are just actually taking the highest order operation, and we have actually seen that this is the linear time complexity. Okay, cool then everyone. Let's meet in the next video.